Hello everyone, I am Dr. Aba Kumari. Today we will discuss some more problem from the differential equation. So the problem today we have taken as solve d2y by dx2 plus dy by dx minus 2y equal to x plus sin x. Earlier we have seen so many cases. In that cases we have seen this separately for the function of exponential, for the function of algebraic and for the function of trigonometric. But here in this question, we will do the question when both the terms for the algebraic and the trigonometric comes together. So let us see how can we solve this question. To solve this question, first we find the auxiliary equation. Okay, so let the auxiliary equation be m square plus m minus 2 equals to 0. And this implies m square plus 2m minus 2 equals to 0. And this will give the solution as m minus 1 m plus 2 equals to 0, and therefore m equals to 1 and minus 2. So here the complementary function is given as CF equal to C1 e to the power x plus C2 e to the power minus 2x. Let us see for the particular integral. Since it is a combination of the two functions, algebraic and trigonometric, so first we take both the together at a time and we write like x plus sin x divided by d square for this one, d for dy by dx, and then minus 2. Okay, and thereafter in the next step we just separate this function. So we will write here x divided by d square plus d minus 2, and then plus sin x divided by d square plus d minus 2. So by separating both these two functions, here we will apply the rules for the algebraic function and here we will apply the rules for the trigonometric function. Okay. While solving this question, we will take the constant term outside so that we get the term as 1 plus x. Because in the previous lecture I have told, whenever we have an algebraic function, we just put the function in the form of 1 plus x so that we can use the formula of 1 plus x inverse. Okay. So here I have taken the minus 2 outside so that we will have here 1 plus d square plus d divided by minus 2 and into x. Then plus sin x divided by, here it is a trigonometric function and here we have 1. That's why we will put d square equal to minus 1 square, that is minus 1. So I have written here minus 1 plus d minus 2. Okay. In the next step we have minus 1 by 2 is outside. We will take both this function in the inverse form. So we have here 1 plus, here is minus sign, so I have taken here, took it here. So 1 minus d square plus d divided by 2 inverse into x, and plus sin x divided by this one minus 3 and then d. So the term will become sin x divided by d minus 3. Now we will use the formula for 1 minus x inverse. So 1 minus x inverse is equals to 1 plus x square and so on. This one. So here it is minus 1 by 2, 1 plus d square plus d divided by 2 plus d square plus d divided by 2 whole square and so on into x. Plus, since we know that while we have a trigonometric function, we just put the value of d square equal to minus 1 square or whatever we have the angle. So we will just change this function into d square. So we have to use the component and divide into, and we multiply this function as d plus 3 divided by d plus 3, both the numerator and denominator, and then into sin x. So here we have minus 1 by 2 x plus, we just take this function into 1 into x, so we have x here. Now d square of x power 1. So multiplying one time we are having here d of 1, and d of 1 is equals to 0. That's why I have written here 0. And then we have d of x. D of x means differentiation of x only one time. That's why we have 1 divided by 2. And the next we have no need to proceed because we have only x to the power 1. Plus, here we have d plus 3. So d of sin x plus 3 sin x divided by d square minus 9. Okay. And the next we have here the minus 1 by 2. So minus 1 by 2. Then x plus 1 by 2. So write x plus 1 by 2 and then plus. Now d of sin x is the differentiation of sin x. So we have here the cos x plus 3 times sin x and divided by, now d square is now replaced by minus 1 square, and that's why we have written here minus 1 minus 9. So this will become equals to minus 1 by 2 x plus half plus cos x plus 3 sin x divided by minus 10. And therefore the general solution is given as the complementary function plus particular integral, and this will be equal to c1 e to the power x plus c2 e to the power minus 2x, then minus half x plus half minus 1 by 10 cos x plus 3 sin x. This is our solution for the given differential equation d2y by dx2 plus dy by dx minus 2y equal to x plus sin x. Let us see one more problem. So the question is, solve d2y by dx2 minus 4dy by dx plus 4y equal to x square plus e to the power x plus cos 2x. In the previous question, I have taken the two terms, algebraic and trigonometric, but here in this question, I have taken all the three cases at a time, that is algebraic, exponential and trigonometric. So let us solve this question. So first we take the auxiliary equation as m square minus 4m plus 4 equals to 0, and this implies m minus 2 whole square equals to 0, and this will give the two roots as m equals to 2 and 2. And therefore the complementary function for this differential equation is equals to c1 plus c2x into e to the power 2x. Since the roots are repeated, that's why I have written here c1 plus c2x into bracket e to the power 2x. Fine. Now let us see the particular integral. For the particular integral, we will write x square plus e to the power x plus cos 2x divided by d square minus 4d plus 4. And first of all, we have to separate all these functions. Whatever we have, the algebraic, exponential or trigonometric, we just separate the function first. So we will write here x square divided by d minus 2 whole square plus e to the power x divided by d minus 2 whole square and plus cos 2x divided by d square minus 4d plus 4. Now we apply the rules here for the algebraic function. So we just take the 2 outside. So here 1 by 2 square is taken the common. So we are leaving with 1 minus d by 2 whole square into x square plus. Now exponential function, for the exponential function we know if we have some coefficient here, then we just put this coefficient value in the place of d. Since it is 1, so we just replace d equals to 1, and that's why this term will become e to the power x divided by 1 minus 2 whole square, and then plus cos 2x divided by, this is d square, and we can change the d square as minus a square, that is minus of 2 square, because 2 is here as an angle. So we will write d square equals to minus 2 square, and this is equals to minus 4. So here we have minus 2 square minus 4d plus 4. Okay. In the next line, we will just write 1 by 2 square bracket 1 minus d by 2 whole inverse minus 2 into x square. We just put this one in the inverse form so that we can use the formula for 1 minus x to the power minus 2. Then plus e to the power x. While solving this bracket, we have here the 1 plus cos 2x divided by minus 4d, because here is minus 4 and here is plus 4. So we are having the 0. So we are getting the cos 2x divided by minus 4. Next, while solving this value, we have here 1 by 2 square bracket 1 plus 2 into x. The formula is, so 1 plus 2 into d by 2. Here is d by 2. So d by 2 plus 3 times x square. So 3 times d square by 4, and then bracket then x square. I am not going to the forward because we have only x square. So we just use the d square plus e to the power x, and then minus 1 by 4 sine 2x divided by 2. Why? Because 1 by d, it means that integration. So we are using here the integration, and integration of cos 2x as what? Sine 2x divided by 2. And while we have written here sine 2x divided by 2. So we are having the here value 1 by 2 square, x square, 2 getting cancelled, d of x square means 2x, only one time differentiation, plus 3 by 4, d square means 2 times differentiation. So while differentiating 2 times x square, we are living with the value only 2. So I have written here 2 plus e to the power x minus 1 by 8 sine 2x. Now this will become x square divided by 2 square plus 2x divided by 2 square. So 2 getting cancelled. We are living with x by 2 plus 3 2 and 2 is getting cancelled, 2 and then 2 and 2 is square getting 8. So we have written here 3 by 8 plus e to the power x minus 1 by 8 sine 2x. Therefore, our general solution for the given differential equation will become c1 plus c2x e to the power 2x plus x square by 4 plus x by 2 plus 3 by 8 plus e to the power x minus 1 by 8 sine 2x. I hope you all understand it very well. If you have any doubt, any query, then please give me a comment in a comment box. Thank you.